Open your book to page 1. Today's lesson is to cover some fundamental concepts of mathematics. So first, let's talk about the line. Now, the line used in this course is not the same as the line in geometry. So if you look on page 1 on the bottom, there are two terms. One is called directed line, and the other one is directed line segment. And the difference between the two is that if you go to page 2, so on page 2, if you notice the picture in figure 1.1, so this is a picture of a directed line. Directed line, it has an arrow to indicate the direction. Now again, this is not in the way in geometry. In geometry, a line has two arrows on both ends. It means it goes on forever. Okay? But over here, the arrow is to indicate the direction, okay, of the line. So again, this is not same as the line in geometry. And the segment, the directed line segment, example of here would be like over here. So this is point A, this is point B, and this is the line segment. So this means this is the directed line. It tells you that the line AB is going from left to right. Whereas the line segment, it tells you it's going from A to B. And notice in this case, the arrow does not mean it goes on forever. Okay? Unlike in geometry, okay, over here it tells you that it starts over here, and the arrow tells you it's going this direction, and it stops right over here. Okay? So again, the arrow tells you where to stop. So it's not same as in geometry. In geometry, the arrow means going on forever. In this course, in analytic geometry, it tells you the arrow, it tells you the direction it's going, and it tells you where to stop. Okay? And the symbol for that is A, B with the arrow on here. So again, it tells you it starts at point A, and you're going toward B, and you stop at B. Okay, so that's what the symbol stands for. And you have to be careful with the line segment because it has a direction. So if you look in the blue box on page 2, it shows you that going from point A to point B is opposite of going from B to A. Okay? So what it's saying is that from point A to point B is equal to negative or opposite of from B to A. So you have to pay close attention with the direction. Okay? So again, these are directed line segments, so it's a direction. So must pay close attention to that. Now, if you use an absolute value, so if you have absolute value, that means the length. So in this case, it doesn't matter about the direction. Again, this one has no direction. This one just tells you wanted the length between point A and B. So this would be same as from B to A. Okay, again, absolute value means length. So length does not have direction. So they would be the same. Whereas over here, it has a direction. So they would be opposite. Okay, so those are some of the basic concepts. Okay. Now let's go to page 3, the Theorem 1.1. So Theorem 1.1. It tells you, it says that if you have a line segment, or you have the line, directed line, you got A, B, and C. Again, the distance does not matter. This is just a picture. So if you look at it, you have an AB plus BC is equal to AC. So what it's saying is that if you start point A, you go to B, and then from point B to C, it's same as going from A to C. So that's what it's saying. So this is how you add the directed line segment. Again, so what it simply means is if you start point A, you go to B, and then addition means continue. So then from there, from point B, you go to C. So when you add this together, it's same as going from A to C. Right? So they're the same. So that's what it's saying. And if you just look at the next one, same thing. Okay, same concept. If you start with point A and you go to C, and then from point C, you go to B. This is same as going from point A to B. Right? Again, you start with A, you go to C, and then from C, you go to B. This is equal to from A to B. And if you look at the next one, you got BA plus AC is equal to BC. Okay. So from there, this means you start with point B. So from point B, you go to A, and then from A, you go to C. So the net result is same as from B, start at B, and you go to C. Okay, so that's how you do the adding. So again, if you just follow the steps, and it's very easy, it becomes very obvious. Now, on page 5, you need to know the quadrants of rectangular coordinates. Again, all these are very basic concepts. Okay, so this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay. Next, let's go and cover how to find the distance between the 2 points. So if you go to page 8, if you have a horizontal distance, so this one is like -2, 4, and this one is 6, 4. So this is point C, this is point D. When you have a horizontal distance or vertical distance, when there's no slope, okay, when there's no angle, okay, in like this case over here, or when it's vertical, okay, when it's not slanted, to figure out distance, think about number line. Okay? So you're going from -2 to 6. So in this case, the distance will equal to 8. So to figure out the distance, all you have to do is use the end point minus the starting point. So 6 minus -2 will give you 8. And same thing, if you have the vertical point, point F at -3, 1, and point E at -3, -4. So to figure out this distance over here, you can use the end point. Now when you're going up and down, you look at the Y. When you're going horizontal, you're looking at the X, right? So when you go up and down, you look at the Y. So Y, the end is 1, and the beginning is -4. So 1 minus -4 will give you 5. Okay. So you can use the end point minus the starting point, and that will give you the distance. Okay. Now when you go to page 9, when the 2 points, on the ninth segment that is not horizontal or vertical, when it's slanted, then what you need to do is you have to use Pythagorean theorem. Okay, so this is like A, B, C, right? So to figure out the distance between these 2 points, just use Pythagorean theorem. So you got C squared equal to A squared plus B squared, right? But sometimes they don't give you the distance. Sometimes they just give you the coordinates. So for example, this is point 1, this is point 2. So point 1, you have a coordinate of x1, y1. The point 2, you have a coordinate of x2, y2. The subscript just means the 2 just means the second point. Okay, so that means the x for the first point, y for the first point. This means x for the second point, y for the second point. Okay. So in this case, to figure out the A, in this case, A, this distance over here, that is your x2 minus x1. Right? Remember, we covered this earlier from here, right? To figure out the distance, use the end minus the beginning, right? So the end, again, this is x, right? So you got x2 minus x1, right? The end minus the beginning, that's that, okay? And the vertical is y. So this would be y2 minus y1, right? Again, use the end minus the beginning. So if they give you the coordinates, you just substitute, right? So, and so you got c squared equal to x2 minus x1 squared plus y2 minus y1 squared, right? And to find the distance, okay, in this case, the c will equal to square root of x2 minus x1 squared plus y2 minus y1 squared. But in the book, they instead of using a c, they use d for distance. So it's the same thing. So be flexible with your symbols or the variables. So this is the Pythagorean theorem using the coordinates. Again, all you do is x2 minus x1. You figure out this distance over here, so this is a squared, right? And this is b, so that's b squared. So a squared plus b squared, and you take the square root, right? That's how you get hypotenuse. Okay, now let's go over one of the example on page 12, and let's do number 37. So this book is a bit challenging because a lot of problems require some thinking. It's not as simple as just get a formula and you just substitute and that's it. Okay, so sometimes requires some thinking, analytical thinking. So number 7, it says find a point on the x-axis that's equidistant from the point -2,5 and 4,1. So whenever you're going to do the problem, it's best to go ahead and draw the picture. It helps you to visualize and help you to think through. Okay. So let's go and plot the 2 points. So first point is -2,5. So this is -2,5. And the second point is 4,1. I'm going to call this point A and this point B. Again, feel free to label them. And so this is 4,1. You're looking for a point on the x-axis that is equidistant to those 2 points. Again, you have no idea where that is right now. Okay, so just plot any point for now. Let's say over here, okay? And we can call this point P. And the coordinate, we know that x coordinate, we don't know. That's what we're looking for. So this x. The y coordinate, we know. Okay, because y coordinate is on the x-axis, so y coordinate will be 0. Next, what you do is you draw your distance. Okay? So let's call this D1 and let's call this D2. Now, obviously, you can see that they are not the same right now, but again, it's okay. Just draw the pictures so it can help you to visualize. Now, the problem is you need to find out where this would be so that they're equal distance. Well, equal distance means your D1 equal to D2. Okay? Right? Again, this point is equal distance to those 2 points. So D1 equal to D2. So in this course, you have to start with definitions. Start with your definition and you work your way through from there. Okay? Then after that, you need to apply your definition of the distance. So the distance, use your Pythagorean theorem, right? Use your Pythagorean theorem. So this is equal to square root of x minus -2 square, right? X, and then the y. And again, because of the square, it doesn't matter which point you use. But I like to use the variable you're looking for. Okay, so you got 0 minus 5 square. So that would be your D1. Next, you need to go and get the D2. So equal to D2. Again, D2 is right over here. So you get x minus 4 square. Right? You can think about your Pythagorean theorem, right? So that's your distance. Plus 0 minus 1 square, right? So that's the distance over here. So next thing, what you want to do is you want to simplify things a little bit and square both sides. Right? You want to go and work your things out, right? So first you square both sides to get rid of the square root, and next you're gonna work these things out. So this one, that's going to simplify things a little bit. So get rid of the square root. So you're going to get x plus 2 square plus -5 square equal to x minus 4 square plus -1 square, right? So simplify things a little bit and get rid of the square root. Next, go ahead and work it out. Let's write this a little bit better. So work it out, so multiply out, you get x squared plus 4x plus 4 plus 25 equal to x squared minus 8x plus 16 plus 1. So make sure you know how to multiply these. You get the middle term, right? Now let's go and solve this. So let's go and minus x squared from both sides, so that they cancel out, right? Next, let's go and move the variable to this side. So let's go and plus ax, so that variable is gone from this side. And I'm going to minus 29 to move this to this side. So minus 29. So I got 12x is equal to, so you minus, you're going to get negative 12. And divide by 12, so x equal to negative 1. So obviously we can see that our point is a bit off. Our point should be right over here. Okay? But that's okay. But you just want to draw the picture to give you something to look at. So the point that would give you equal distance would be the point negative 1, 0. And that would be your answer.